Hello everyone. In previous lectures, we have already studied the protection and deprotection of various functional groups like alcohol, diol, carboxylic acid, aldehyde, ketones and amine group protection. In this lecture, we have to study the solid phase peptide synthesis and also the application of amine group protection. We know the peptides are the drugs and more than 40 marketed peptides are the worldwide, 270 peptides in clinical trials and 4000 peptides in advanced preclinical phases. So before starting the application of amine group protection, we have to know what are peptide. So what is peptide? This is the compound consisting of two or more amino acids linked in a chain, the carboxyl group of each amino acid being joined to the amino group of the next by a bond of the type C double bond O bond NH. This bond is called peptide bond. And when a molecule consists of 2 to 50 amino acid, it is called a peptide, whereas a larger chain of greater than 50 amino acids generally referred as proteins. So the polymers of amino acid that are linked by peptide bond, the protein is a polypeptide. The coupling of two amino acid in a solution to gives the peptide bond. The unprotected amine of one react with the unprotected carboxylic acid group of the other amino acid to form the peptide bond. Here two amino acids are given. In this amino acid, the amine group is protected with the protecting group P1 and the acid group is free for the reaction, while in the next amino acid, the amine group is free for the coupling with this acid and the acid group is protected by means of this P2 protecting group. And when these two amino acids are coupled, we get a new peptide chain in which this is the C double bond O bond NH, this peptide bond. This is the new form peptide linkage. So the coupling of two amino acid in solution to gives the peptide bond, the unprotected amine of one react with the unprotected carboxylic acid group of the other amino acid to form the new peptide bond. There are two types of peptide synthesis, solution phase peptide synthesis and solid phase peptide synthesis. The formation of peptide bond using the solid support material, then it is called as the solid phase peptide synthesis, and it was invented by the Bruce Merrifield in 1963 and he got the Nobel Prize for this in 1987. Therefore, the synthesis is also called as Merrifield solid phase peptide synthesis. In this solid phase peptide synthesis, the starting material is bonded to an inert solid support and the reaction occurs at the interface between the solid and the solution because the starting material is bonded to the solid and any product from the starting material remains bonded as well. The purification involves simply washing the byproducts from the solid support. Then the first step is to attach the starting molecule to the inert solid, and typically the inert polymers are resins are used for the synthesis. They are commercially available. Since the molecule is attached to the solid, any other chemicals added or products can be removed by simply filtration process. After all reactions are done, the product is still attached to the insoluble bed. This is the first amino acid in which the amine group is protected with the help of FMOC protecting group and the carboxylic acid is free for the reaction and it can be activated In this amino acid, A group is activated for this acid. Therefore, here we write the A except the carboxylic acid group, and when this amino acid is react with another molecule of amino acid in which the acid is protected and the amine is deprotected or the free for coupling, and when these two amino acids are coupled we get a new peptide bond or this new peptide linkage. And this reaction is continued till the required peptide and polymers are not obtained. And in last step there is a deblocking or deprotection, because here the amino acid is in this amino acid the amine group is protected and also the carboxylic acid is also protected with this resin. Therefore, to free this amine group for next coupling there is a deprotection of this FMOC protecting group. See again, this is the first amino acid in which the carboxylic acid is free for the coupling and the amine group is protected by means of FMOC protecting group. Here A is the solid support, P1 and P2 are the protecting groups for the side chain. In this the P2 is the protecting group for this chain. In this the P1 is the protecting group for this side chain. The FMOC is a protecting group for amine. This A1 is the amino acid first, A2 is the second amino acid, and resins are the solid support for this acid. So this is the first amino acid in which the amine group is protected with the help of FMOC protecting group, and it is activated by using A group. The acids are activated, therefore here we replace the carboxylic this OH with the help of this A, that is the activating group for the acid, and this amino acid is react with the next molecule of amino acid with the in the second molecule of amino acid the amine group is free for the coupling and the acids are protected by means of these resins, and there is a coupling between two amino acid, that is amino acid first this and amino acid second, and here we got the new peptide linkage. This is the peptide bond and this process is repeats. This reaction is continued till required peptide and polymer obtained. This is the first peptide, and after the repetition here we get the protected form of amino acid first in which the amine group is protected. So for the repetition of this reaction there is need to deprotect this FMOC group. Therefore here it is a deblocking of this FMOC group, and after the deprotection here we got the free NH2 group. This is ready with the reaction of this amino acid second, and again there is a coupling between this amino acid first and second, and finally we got our desired polymer or a peptide linkage. This is free amine and here it is a polymer. When it is react with this group second amino acid here the amino acid in which this is the protected form of this second amino acid, and when these two are coupled we got this type of peptide linkage, where the X is a FMOC or a BOC. The FMOC or BOC are the protecting group for this amine, and they repeat the deprotection and coupling. Here there are number of peptide bonds are synthesized. Therefore, this is called a polymer or a peptide linkage. And in last step, there is a cleavage or a deprotection. And after the deprotection, we got the peptide and polymer. So, what are the difference between the solid phase peptide synthesis and solid solution phase peptide synthesis? The solution phase peptide synthesis it is a time consuming process, while the solid phase peptide synthesis is a time fast process. The solution phase peptide synthesis can be carried out by the large scale, and the solid phase peptide synthesis it can be carried out by the small scale. The purification is required after each step when we prepare the peptide by using the solid solution phase peptide synthesis, but the purification is required after the completion of reaction in the solid phase peptide synthesis. The solution phase peptide synthesis is a cheap process, while the solid phase peptide synthesis is expensive process. This is the all about solid phase peptide synthesis. I hope you understand. Thank you for watching.